Assalamualaikum. So today we're going to learn chapter 5, which is work, energy and power. Okay, so for the first subtopic, we are going to focus on work. Okay, we're going to learn what work is. Okay, so for your first learning outcome for this chapter is define and apply work done by a constant force. So when you define, you have to use either you can state it in words, or you could also give the equation. So let's see both of it. So for the first one, define. So you should be able to define work. So work is defined as a scalar dot product between force and displacement of a body. Okay, scalar dot product. Okay, so if you remember what a scalar dot product is, we have learned this in chapter 1, where A dot B, where A dot B equals to AB cos theta. Okay, AB cos theta. So this is a scalar dot product. Okay, so before that, what is work? Okay, work is a scalar quantity. Okay, it's a scalar quantity. Okay, work is a scalar quantity. So therefore, a scalar quantity does not have direction. Okay, work is a scalar quantity and it does not have direction. Okay, so work is defined as a scalar dot product between force and displacement. So if we write it, it's going to be work equals to F dot S. Okay, and using this formula, using A dot B equals to AB cos theta, therefore F dot S is going to equal to Fs cos theta. So work is going to equals to Fs cos theta. So this is our equation for work, which is Fs cos theta. Okay, where W is work, okay, S is the displacement. Okay, it's the displacement, how far the object has traveled. Okay, it's the displacement. And theta, okay, very important, theta is the angle between, okay, theta is the angle between, okay, angle between force and displacement. Okay, force and displacement. Okay, so work is sebenarnya kita buat kerja. Okay, so when kita buat kerja, mestilah kita akan buat kerja, kita akan gerakkan benda tu. Okay, we will move it from one point to another. So that would be our displacement. Okay, and F is the force. How much force is exerted to do the work? Berapa banyak tenaga yang kita perlukan? So how much force is exerted, how much force kita bagi kepada sistem itu to do a work. Okay, so that is work. Okay, so it's defined as a scalar dot product between force and displacement, or you could also write it in words where W equals to F dot S. So F is a vector and displacement is also a vector. Okay, but when we open the dot product, we will get a scalar quantity, which is work. Okay, so this is what work is. However, okay, before that, the unit for work is joules. Okay, the unit for work is joules. Okay, however, even though work is a scalar quantity, we can also get a positive and negative direction for work. Okay, but since it's a scalar quantity, so the positive and negative here does not represent the direction. It has a different meaning. Okay, so if we get our work done to be positive, okay, work done to be positive, that means work is done on the system. So bila kita kata work is done on the system, that means ada external force daripada luar yang membuat kerja ke atas sistem itu. So the work is positive. So work is done on the system, okay, from the external. However, kalau kita dapat work kita negatif, okay, kita dapat nilai work kita adalah negatif, it does not represent the direction. Tak adalah dia ke kiri atau ke bawah, no. So kalau kita dapat work kita negatif, that means work is done by the system. Okay, work is done by the system. So maksudnya sistem kita yang buat kerja. Okay, the system yang buat kerja. So there is two possibilities. Sama ada kita dapat work kita nilai yang positif ataupun work kita nilai yang negatif. Kenapa kita boleh dapat work kita nilai negatif? sebab kita ada theta kita kat sini. So for example, if your theta equals to 180 degree, you boleh dapat work kita negatif. Okay, tapi if your theta is 0, then you get the maximum lah. The maximum work done, that one would be positive. So theta kita yang menyebabkan work kita menjadi negatif. Okay, and the force dekat sini, okay, the force dekat sini, it can be any 5 of the forces that we've learned in chapter 5. Okay, we've learned 5 forces in chapter 5. Kita ada normal force, kita ada weight, kita ada tension, kita ada friction, kita ada external force. Dia boleh jadi antara mana-mana 5 itu, which will be our force. Okay, force untuk kita buat kerja itu. It can be any 5 forces. Okay, so that is about work, a brief introduction about work. Okay, and there is also a condition. Okay, a condition. Okay, when our work would equals to 0, when no work done and work done akan equals to 0. Okay, so if you see the equation here, work equals to Fs cos theta. Okay, so work akan menjadi 0. Okay, there is 3 conditions, sorry. So the first condition, work kita akan menjadi 0 when force kita is 0. Okay, when our force is 0. Apa maksud force kita 0? Remember Newton's first law. Okay, if it's moving with a constant velocity, if it's at rest, if it's moving with a constant speed, so force kita akan menjadi 0. So bila force kita menjadi 0, work kita pun akan menjadi 0. So if we have F kita kat sini 0, automatically work done kita akan menjadi 0 lah. So force kita akan menjadi 0 when our net force, okay, net force equals to 0. Okay, bila net force kita equals to 0, contohnya bila dia bergerak dengan constant velocity and etc lah. Okay, bila dia at rest, bila dia at stationary, force kita akan menjadi 0. Okay, yang kedua, adalah work kita akan menjadi 0. Okay, the next one we have Fs cos theta. Bila kita tak ada displacement, maksudnya ibarat kita tolak dinding, kita bagi force yang maksimum ni, kita tolak dinding, tapi dinding tu tak bergerak. So if there is no displacement, if there is no pergerakan, okay, there is no beginning and the end point, there is no displacement, and S kita equals to 0, okay, work done kita, it will also be 0. Okay, so work done kita akan jadi 0 because there is no displacement. Okay, so far ada 2, sama ada net force kita adalah 0, okay, ataupun displacement kita menjadi 0. Okay, displacement kita menjadi 0. And yang ketiga adalah theta kita. Okay, yang ketiga adalah theta kita. Another thing that could cause work kita untuk jadi 0 adalah besides F and S is our theta. So kita nampak kalau theta kita equals to 90 degree, there is no work done. Okay, contoh kita apply a force. Okay, kita apply force kita ke kanan. Okay, tetapi displacement dia ke atas. Contoh, so angle between the force and the displacement is 90 degree. So dia tak akan ada work done. So if theta kita equals to 0, there is no work done. Okay, so these are the 3 situations when work done kita equals to 0. Okay, so that's about work. So you have to remember work is a scalar quantity. Okay, and the equation for work is W equals to Fs cos theta. And theta is the angle between the force and the displacement. Okay, the force can be any 5 forces that we have studied in chapter 4. Okay, and work done is said to be positive bila work is done on the system. Okay, kalau kita dapat nilai yang positif, maksudnya external force tu, external daripada luar tu yang membuat work ke atas sistem. Kalau kita dapat work done kita negatif, maksudnya sistem kita yang buat kerja. Okay, work is done by the system. And remember, theta is the angle between our force and our displacement. Okay, so that's a brief introduction to work. Okay, so kita move to the next part. So your next learning outcome is for you to be able to apply work done by a constant force. Okay, so for this part kita akan tengok contoh-contoh work done situation. Okay, so for the first one, okay, this one is the first one. Okay, kita zoom in sikit. Okay, so for the first one, we have, kita nak cari work. So kita tulis dulu formula work. W equals to Fs cos theta. Okay, and then kita check dulu theta kita equals to berapa. Okay, tengok Miss tunjuk your force ke kanan. Okay, and your displacement also ke kanan. So angle between the force and the displacement is going to be 0 sebab dua-dua ke arah yang sama. So theta kita akan menjadi 0. And if you tekan calculator, cos 0 equals to 1. Okay, therefore W akan equals to Fs sahaja sebab cos 0 dah equals to 1. Apa-apa darab 1 kita dapat balik nilai tu. Okay, so work kita akan menjadi Fs. Okay, so this is for the first situation. Okay, situation yang kedua. Okay, situation yang kedua sama juga. Miss tulis dulu equation dulu. Work done equals to Fs cos theta. Okay, dan kita check theta kita equals to berapa. So now we have our force moving upwards and our displacement is moving towards the right. Okay, so the angle, the angle between the force and the displacement is 90 degree. So bila angle between the force and the displacement is 90 degree, if you press your calculator, cos 90 you akan dapat kosong. So everything becomes 0. So work done it was going to be 0. Okay, sebabkan angle kita. Okay, yang ketiga, kita ada dua force. We have two force. Two force is been exerted. So bila kita ada dua force, akan ada dua work done lah. Akan ada dua work done on the system. So kita buat satu-satu dulu. So for work done yang pertama, disebabkan oleh force yang pertama. Okay, disebabkan oleh force yang pertama, displacement dia samalah. Okay, disebabkan dua force tu dia akan bergerak ke tempat yang sama. So F1S cos theta. Okay, yang kedua is work dan yang kedua disebabkan oleh force yang kedua, S cos theta. Okay, so what happens is kita check dulu angle kita. For this one, force kita ke kanan, displacement kita pun ke kanan. F2 pun sama, force kita ke kanan, displacement kita pun ke kanan. So for both cases theta kita equals to 0 degree. Okay, so when theta kita equals to 0 degree, kita akan dapat sum of our work done. Okay, sum of our work done is actually equals to force 1 plus force 2. Okay, kita boleh tambahkan dia sahaja darab dengan S. So cos theta ni dah tak adalah sebab cos 0 equals to 1. Okay, so total work done is force 1 tambah dengan force 2 darab dengan darab dengan S. Okay, ataupun total work done kita, we can represent it as F net. Okay, total force darab dengan S. Okay, total force maksudnya tak kisahlah berapa force kita ada kat sistem kita. Contoh kita ada force satu external force ke sini, lepas tu tiba-tiba ada juga external force lagi satu ke sini. Contohnya dua orang tolak kotak tu, so ada dua external force. So kita tambahkan external force kedua-dua orang itu, dan yang itu akan menjadi F net kita. Okay, so that one adalah untuk case yang kedua. Okay, untuk case yang ketiga pula. Okay, case yang ketiga sama juga, kita ada dua force, cuma bezanya force kita ke arah yang lain. Satu kita ada force ke atas kat sini, and another one kita ada friction kita ke belakang. Okay, so based on our earlier equation, kita tahu work net ataupun total work equals to F net darab dengan displacement. Okay, so F net kita adalah total force kita. So we have studied daripada chapter 4 total force. Kita akan ambil X component yang ke kanan tolak dengan yang ke kiri. So yang ke kanan ni kita akan resolvekan dia lah kepada Fx and also Fy. So kita tak perlu kisah pasal Fy sebab sekarang kita guna untuk X component. Kita nak ambil Fx kat sini and also friction dekat sini. Okay, so dia akan menjadi F cos theta. Okay, kenapa cos? Sebab theta kita berada in the X component tolak dengan friction. So this is our total force. Okay, therefore work done net kita, so kita akan gantikan F net kita ataupun total force kita ke dalam F net. Okay, so kita akan dapat total work net done equals to F cos theta tolak dengan friction. So this is our total work done ataupun net force. This is our net force darab dengan displacement. Okay, so kita cari je net force. Net force ni sama macam kita cari yang kita duk cari total sum of force dekat X dengan Y component tu. Kita cari je yang itu dan kita masukkan. Okay, tapi yang kat sini kita still kena consider direction lah sebab kita nak cari total force. Force is still a vector quantity. Yang scalar quantity sekarang adalah work. Okay, so this is going to be our equation yang keempat. So this is example of cases. Bila kita buat soalan nanti, then you akan nampak lebih lah. Okay, so this is how you apply work done. So ingat, make sure you check your theta. Okay, make sure you check your theta. Draw your force direction, draw your displacement direction. Then cari angle between theta you adalah berapa. Okay, so that's how you apply. Okay, then kita pergi to the final learning outcome untuk this subtopic. Is apply work done by a constant force from a force displacement graph. Okay, so we have a work done by a constant force from a force displacement graph. So dalam exam, if you are given graph force against displacement, okay, if you are given graph force against displacement, area under the graph, okay, area under the graph dia adalah work done. Okay, so remember, kalau nampak je graph force against displacement, dia minta awak cari work done, awak cari sahaja area under the graph. Okay, cari sahaja area under Fs graph. Area under Fs graph equals to work done. Okay, so that is your third learning outcome.